proportion. If we have a shape, let's draw a hexagon for example, and we're going to have a side length t with an area of m. So this could be t centimeters and m centimeters squared, or any units that you like. If we increase t, so we increase the side length, then as you can see, my not very good drawing, t has got bigger, so m has also got bigger. And so that means that we can say that t is proportional to m. Note that this isn't the infinity sign, but it looks more like a Greek letter alpha. Okay. So t is proportional to m. So as t gets bigger, m gets bigger. As t gets smaller, m gets smaller. And we can also write this as t is equal to km. And we call k here the constant of proportion. So depending on what k is, will depend on the difference between t and m. So what sort of question do we have here? So if we have that when t is equal to 20, let's run that again, 20, then m is equal to 4. We want to find t when m is equal to 6. So this is a question. So remembering that t is our side length and m is our area. So the first thing we want to do with t and m is to find our constant of proportionality. So this, our k. So to do this, we're going to substitute t and m into our equation. So we're going to have that 20 is equal to 4k, and I've just switched the k and the 4 around just so it is a bit easier and looks better. That's just convention. You could have k4, but I prefer 4k. So now we can find k just by dividing both sides by 4. And all we're doing here is getting this k on its own. So that'll give us that k is equal to 5. So now we've got our constant of proportionality. This means that given any t or any m, we can find the converse. So if we've got a t, we can find m, or if we've got an m value, we can find the corresponding t value. So let's now substitute in m equals 6 into our equation. So we've got that t is equal to 5m. So m is 6, so t is equal to 5 times by 6. So t is equal to 30. So what we've done here is we have stated that t and m are directly proportional. So when t increases, m increases. We have then found some using an initial starting point of 20 and 4. We found our constant of proportionality and then found t when m equals 6. So now let's have a look at inverse. So inverse proportion. If we say that A is inverse the proportional NaL inversely proportional to B. What does that mean? Well, what it means is that as A gets bigger, then B is going to be getting smaller. So here we can say that A is proportional to 1 over B. We don't have a symbol for inversely proportional, so we just say that A is proportional to 1 over B, and that's the same as inversely proportional. So again, here we can find a constant proportionality. So A is equal to K over B, and K again is our constant proportionality. So if we were to look at a question, we could say that the initial values, A is 2 when B equals 5, and we want to find A when B equals 10. What is a 10? Okay, so we've got our values and we do exactly the same thing as we did over here. So first of all, we're going to substitute our values. So 2 is equal to K over 5, which if we multiply both sides by 5, we'll find that K is equal to 10. And all I've done now is multiply both sides by 5, and then I swap the sides over because I prefer writing K equals 10. So now we have our inverse proportionality to say that A is equal to 10 over B, because we now know what K is. So we want to substitute in when B is 10, which comes out quite nicely because that gives us 10 over 10. So A is equal to 1. So now we've seen how to work out proportionality. Let's just try to understand why A is directly proportional to 1 over B is the same as A is inversely proportional to B. So think about what happens in the graph, that as B gets bigger, so if we double the size of B, then we're in fact halving the size of A. And that continues on across the whole graph. If we halve the size of B, then it is the same as doubling the size of A. And that is proportionality and inverse proportionality, and how to work it out. I hope it's been useful. Thank you for watching.